So here in week 2 of our Cie101 Civil Engineering Graphics, I'm going to talk about project delivery methods within the construction industry, the design industry, and the relationships that we have with the different groups. There we go. In all construction, it says traditional construction, but really all of them, we have 3 main parties with multiple contracts. We have the owner, we have the designer, and we have the constructor or contractor. Construction management is also there if needed with the owner. Sometimes we hire a construction manager to work with us to help promote the time frame and getting the work done. And sometimes we use what's called a construction manager at risk. But the 3 main principal players in any construction job are the owner, designer, and the contractor or constructor. And we have several different delivery methods that are available to us. Our more traditional delivery method is DesignBuild, which is kind of a sequential, linear type construction method. We have DesignBuild, and we'll look at the function of DesignBuild. And we have Construction Manager, and we have 2 types of construction management. It's where a construction manager is hired by the owner to represent them and make sure that the work gets done. And then there is Construction Manager at risk, where the construction manager is actually the contractor. And for a GMP, or guaranteed maximum price, they will build the building or structure or bridge or whatever it happens to be for a fixed fee based on the fact that they are involved in the project during the design process, and we'll talk about that a little further on. Each method does have its pros and cons. Each is subject of well-developed contract forms incorporating years of experience, jurisprudence, and whatnot. Now, these forms come in various families, and they're administered and developed by different groups in the industry. The University of Maine, for instance, uses AIA forms. AIA is the American Institute of Architects, and if we can kind of look at these, I think I put a link on this so we can go take a look at it. Hopefully this works. Here is the American Institute of Architects. They advocate their contract documents are available, and you can purchase their contract documents. So anytime you're involved in these groups, whether it's AIA or other, you can purchase individual documents for the specification requirements or the contract requirements. For instance, contractors would need to purchase a document. Let's see if I can get into this. For a requisition. If they want to requisition money from the university, they can purchase these documents, and they are available per license. You can get 100, 300, and it's kind of money based. So I'm not sure if they give a list of what the documents are, but you can certainly pick out what you need and purchase those. So sometimes contractors get caught up in the fact that they need to purchase these documents in order to give us a bill when we're using AIA documents themselves. So AIA is the American Institute of Architects. They do have a website. Pretty much everything in here has a cost involved in it. There is some areas for education that are available. Not sure what they offer for free, but this is an expense that needs to be looked at when you're an architect or a contractor. That membership in AIA gives you the ability to download and use these forms. Another form is from AGC, which is the Association of General Contractors. We'll take a look at their website. Association of General Contractors has forms available, and isn't it interesting that The Association of General Contractors makes forms available for construction work, and American Institute of Architects makes forms available for construction work. And I think what you'll find when you look at each of these different outfits, these different groups, that the forms are generally written in such a way that it puts the least amount of liability on the person putting out the forms. AIA forms rarely give the architect any major responsibility cost-wise on any problems in the job. As with the AGC, I'm sure it kind of leans towards not giving the contractor as much financial responsibility for errors and omissions that come up within the drawings and the specifications and the construction itself. DBIA is the Design Build Institute of America. We'll take a quick look at their website. Design Build done right. This is where the owner hires one outfit, one engineering contractor firm to build their structure. It's generally for a relatively simple project like a steel building, or something that's pretty much pre-engineered, and then they can design the building and build it under one group so that the owner just has one contract. They do offer a space here for students and faculty. They have a design build competition, some different references, some core curriculum things, and again, it is out. They do have different student chapters. Design Build Incorporated. I don't know if the University of Maine has a Design Build. I don't think so. We do have a. If we go back to AGC for a second, we do have a student chapter somewhere. Education. Student chapters, there we go. And if we look at the AGC student chapters, I believe down here near the bottom, the Black Bear chapter of the University of Maine in Orono, Association of General Contractors, was established in 1990. So we've been around for about 23 years. It is an active group within the university, so if you're interested, you could get in touch with that group. I'm sure they have a website on campus. The last one, we don't see this one too much, is the Engineers Joint Contract Document Committee. Similar to AIA, they provide construction documents and contracts for owners to use, and again, it would probably lean more towards protection of the contractor themselves, or excuse me, the engineer. If we look here at what's new in the EJCDC files for what they've added to their system, let's see, I haven't actually loaded this up, but this is their PowerPoint on. They added 3 new documents, for instance, Cie101 advertisements for bids, qualification statement, subcontracts, instructions to bidders, general conditions, other things. I'm not sure if they give any examples of them here, but insurance highlights, for instance. Insurance companies must have AM best rating of A-V11 or better. Owner and contractor must provide copies of required policies and endorsements upon the others or any additional insured request. Added contractors' pollution liability requirements covering contamination caused or worsened by the contractor. Added contractors' professional liability insurance requirement. These things are all part of, you can see this is written by the engineering company, and it's putting more of the burden in some cases onto the contractor. So I'm sure when you see If we were to go take a look at the contract documents for the Association of General Contractors, their documents would probably put more of the weight of responsibilities towards the engineering or the owner in this case. So these are some different forms that can be used in the specifications of building construction of any type, bridges, roads, whatever. All would reuse these forms, and the forms are made up of front-end documents, general conditions that cover basically everything, and then specific items within the project would be covered under other spec sections, and we'll look at those a little later on in the semester when we start talking about specifications and drawings in general, and we have an example of that in some of the files that you have out there. So we'll look at design, bid, build, competitive. The owner hires an architect to design a project and prepare complete construction documents. Those include plans and written specifications. For every drawing component, everything on the drawing would have a specification to cover the information. Now, when we look back through our construction documents for buildings that were built back in the 20s and 30s and 40s, we find a set of plans that might be 6 or 8 sheets, and we find a specification document that was hand typed, and it might be 3/4 to an inch thick binder. In today's world, those construction documents, the plans are hundreds of sheets of plans and multiple volumes of specifications to cover everything you can imagine. Fortunately, with the use of computers, it's easier to put those together, but the legalities of what is being put together become somewhat mind-boggling after a while. So once you get used to it, it's not bad, but there is a tremendous amount of paperwork that more and more we're trying to convert digitally into some form that doesn't take up quite as much space. You basically need a warehouse to house most of this stuff. In this design, bid, build process, the construction documents used for bidding are created by the architect, and the contractors will bid this as the low bidder. Owner selects and hires the contractor based on lump sum cost or cost plus. Oops, sorry. There we go. So we have a sequence here where we have an owner, has some money. He hires an architect. The architect hires or talks to consultants. Now, who are these consultants? Generally, a consultant might be a door and hardware company that wishes to, quote, assist the architect with building their specifications, and they will provide the architect with specifications, believe it or not, for their particular product. The architect may or may not include those in their specs, but certainly if a consultant knows that an architect is working on a particular project, they may, call them up for a friendly chat and ask them what type of products are going to be used in the project, and maybe make a few suggestions. And if the architect is receptive, you can offer to write some specifications for them, and they are more than happy to take those Word documents and include them in their specifications if they fit the project. Over on the other side, the owner also has a contract with general contractor, the low bidder in most cases. The general contractor has subcontracts with individuals who supply doors and hardware, electrical supplies, plumbing fixtures, HVAC equipment. These are all subcontractors that would work with the general contractor. Now, in an ideal situation, the consultant who did the design work with the architect may also be the subcontractor who's doing the supply and installation for the general contractor. Other cases may be that the person that did the design work didn't get the job, or this GC shopped some things out and used a different person or different company to supply the material, and they may have gotten a product of equal quality for less money, and we're able to do that, and provided that the architect and the owner approve that material, that may be fine. So the consultant may be taking a bit of a gamble, and what the consultant's main purpose is to try to get the architect to specify their product in such a way that it limits the competition from supplying their product. And in most cases, especially with a university where we're using public funds, we need to make sure that the specifications are open enough that we don't make an item a proprietary item. We have to always put in the note or approved equal in our specifications, so that it gives the opportunity for another contractor, subcontractor to come in and say, we got this product, we think it's equal, we'd like you to take a look at it. If you think it is, do you think we can bid it? The architect would say, well, we think so, well, let's check with the owner. The owner comes back and says, yeah, that seems like it's okay. The architect goes back and says, yeah, go ahead and bid that product. And they may put an addendum out that says this also is an available product. So it becomes a very dynamic conversation between architects and contractors and owners to determine what exactly is the right thing to supply for the project. And we don't want to make it too cheap, but we don't want to make it so expensive that it becomes an issue. So the sequence of design, bid, and build is very linear here. It gets done in a straight line, and it's generally done when there's time available. There are three phases and three prime players: the independent contracts between the architect and the owner, and the contractor and the owner. Now if we go back to this other slide, you'll notice this dotted line between the architect and the GC. They don't have a contract. There are no contractual relationships between the architect and the GC other than a communication line. Their project manager may call up the architect's project manager and say, what do you think about this? Or they put in an RFI, a request for information, after the job is done, and the architect will supply them with information. But if a problem arises on the construction site, any financial issues are contractual back to the owner. Any issues with the design problems are with a contract with the owner. So sometimes there is a conflict after the job starts between the general contractor and the architect as to who's responsible financially to make sure that this is going to work. It is a linear sequence of work, common with public owners with public money, with requirements to select a low bidder. Now I put an asterisk on this that says it is a requirement, but it is a requirement that we select a low bid pending the low bidder's ability to be fully bonded and insured, meet all the bidding requirements, and really dot their I's and cross their T's. I have seen large contracts be voided for the low bidder because a signature was missing from their submittal, from their project file, or some piece of information was not there. And there are ways that we can say, if you know that the low bidder is not always the person that gets the project. The university, for instance, reserves the right to reject bids that they feel are not in the best interest of the university. That may get into some legal issues, but we do put that requirement note in there that we do have the right to not accept the lowest bid based on the fact that they may not have the ability to get fully insured and bonded. Now, a bond for a general contractor is an insurance policy that says to the owner that they are insured if something happens and this company goes belly up, goes bankrupt, loses its ability to complete the work, the insurance company will step in and finish the work for them with that insurance policy. Now, contractors don't get too many chances on this. If they screw up with a bonding company once, they will find it's very expensive to get bonded again. So there's two options then. They just go out of business, but they can also come back under a different name. So we see this happen a lot. So bonding insurance companies are very conscientious about who they bond and how much risk they want to put into them. The advantages of design, bid, and build: it's common, it's familiar, people know how to work it. It is a linear process. The design is complete prior to construction. We've tried to anticipate everything we possibly can in this project, and we fully defined the scope. Clear roles are assigned to each party. Competition leads to the lowest price. Both design and construction teams are accountable to the owner. I'm not sure if that's an advantage or not, but where this kind of falls apart, and maybe it shows up here in the disadvantages, you can see the three phases of construction or contractors. This one is angry that something's happened. This one just doesn't know, and this one is just questioning. So we see this face a lot from the owner's standpoint when the contractor is unable to perform for some particular reason. It is a lengthier process. Price is not known until the bids are received. Now, may lead to redesign and rebidding if budget is exceeded. Sometimes we also refer to this as value engineering. And I should put that in the slideshow, because in the construction world, you're going to hear the word value engineering. Value engineering is basically taking the project, sitting down with the low bidder and saying, what can we do to get this project in budget for the amount of money we have without having to go back out to bid. Now, that's an advantage to the low bidder, because they want the job, and they will look at ways to make the job less expensive and give you ideas. Sometimes those ideas are not ideal for the situation, but may allow you to proceed. And generally what we look for, I'll refer to it as low-hanging fruit, are items that could be added back into the project at a later date without having to rework anything that's already been done. It might be an HVAC system. It could be some furniture that we would take out of the project, built-in furniture that we could put in later. It could be a number of things, anything outside or superficial to the project that could be taken out. Maybe we take the landscaping and we cut back on that and don't put the plantings in, or do the plantings on our own time. So those types of things that the owner might be able to take care of themselves, we look at first. We don't want to build something and say, okay, we're going to take out the HVAC system on the west wing and not have any air handling over there. Well, that's great, and it's going to save you money, but when you do have the money to do that and people are complaining that they're too hot or too cold, then we need to tear things apart to put it in. We don't want to do that. We want to keep those things that are permanent to the building in place and take out anything that might be above and beyond that or could be added later. I put in red down here. Change orders and delay claims are more likely in a design bid build. There are things that the architect may have slipped up on, may have made some general statements in the design process, in the specifications, that leave the contractor open to interpretation. If they're not totally specific on how they want something done or the product that's going in, the contractor is going to use the least expensive method to do that. And when the owner and the architect look at the submittals that come in from the contractor on what they're proposing to do, these are the shop drawings and submittals from manufacturers, they may say, oh no, that's not what we wanted. And they look at their specs and say, well, yeah, we kind of left that open. It gives the contractor the ability to write up a change order saying, if you want this material, you're going to have to pay me extra amount of money. So that becomes problematic sometimes when you have a less than adequate design and specification that has been put out that leaves a lot of areas open for interpretation, and that's where we get into that multiple volume of specifications and more pages of drawings. It really requires somebody to sit down and be very specific. Now, there are times when contractors get caught because they haven't read things thoroughly enough in the general conditions that we say, oh no, you're going to supply that, and we can kind of put contractors in a bad situation. It's not intentional, but we have to protect whoever we're working for. If we're working for the engineer, we're looking to protect ourselves there. If we're the owner, we're going to protect ourselves there. And if we're the contractor, we're going to try to protect ourselves. So as civil engineers, you could end up working for any one of those three factions and be an advocate for them in the field by reading through everything and making sure everything is up to speed. Design build is the other process that is more of a fast track deal. The owner hires both the designer and the builder as one entity. Sometimes you may end up with an architectural or engineering firm partnering with a general contractor as a team to become a design build entity. And everything is directly related between the owner and the design builder. So there is one line of contract and communication. You can see it in this chart. The owner has a contract with the designer and the builder. Again, we have a consultants out here for different products and materials for both supply and installation. And again, those sub-consultants could be the same as the subcontractor, but everybody has a contract. The consultant, I would question whether it's actually a contract. It's more of a communication line. I would probably show that more as a dotted line at this point, because there's really no contract between the consultants and the designer builders. It's more of an understanding that they'll try to use their product in their specifications and drawings, and if everything works out, they may end up getting the job to supply it. But generally speaking, these consultants are doing the work voluntarily in order to try to increase their business. Owner contracts with a single entity, single point of responsibility, not legal in all states for public projects where lowest competitive bid is required. There is an opportunity for some illegal activity with a design build, some negotiations that may not be totally above the table, so it becomes less transparent in a design build opportunity where you have contractors that may be pointing the fingers at somebody saying there's something going on here that's not right. So when you're using public money, tax money, to build something, some states do not allow design build. In the state of Maine, we are able to do it, but really we have to be very above board on what things are costing and who's doing what. There are advantages. Certainly there's a time advantage, enables fast track delivery. Early GMP, or guaranteed maximum price, reduces the owner's concern with cost overruns. In a design build, what areas could you see a change order coming up in? Chances are there's probably something built into the specifications where when they're putting in the foundation and excavating for the site, they run into ledge or something that needs to be blasted that was not detected during the site analysis. There could be some additional costs involved in that. And of course, the worst thing that can happen is what we call scope creep. Scope creep is where the owner during the construction process makes a decision to change something or add something to the project. Becomes very expensive. The contractor design build outfit already has a contract. You ask them to add some more doors and windows or some more expensive flooring or something above and beyond the original concept or the scope, you're going to pay. and sometimes you pay dearly. So it's very important to make sure that what you've designed is what you want, and that when people come in and say, geez, it'd be nice now that I'm seeing it built that we add this, that you kind of have limited them to what they can do. Again, disadvantages, design build, I put in here. Design is completed after GMP is given, making change more difficult and costly. Again, scope creep. Architect is not under a separate contract with the owner. Who is watching out for the owner? So there's a good chance if you're working with a design build company that their responsibility, their dedication is not with the owner. It's with making sure that they get out of this project and make some money. So they may not be in your best interest. You may end up with a product that is less quality. The door hardware may be lower hardware. It gets broken easily. They've just made the thicknesses of metal minimum as opposed to what was really a nice construction. So that's why you see design build used more in the steel building industry. They make some great buildings, but sometimes it's again, who is watching out for the owner becomes questionable with a design build contract. There is also a design build as a developer or a turnkey, where the design builder actually maintains and ownership of the structure and basically leases it back out to the owner. So I think we've seen this a few times where a builder will come in, build something, they take care of the maintenance and the operation of the building, they take care of the real estate development, all that stuff is taken care of. So it becomes a little bit more complicated as to ownership rights when we look at this, and we don't see it very often. Construction management is something that we see more and more in the state. I've been involved in a couple jobs where there's been construction managers hired. One is the Alphond Arena renovation recently, and I believe the new Fieldhouse renovation is by construction manager. Construction manager can be hired by the owner, and they are working for you to make sure that the construction and the design is done in a way that is most beneficial to you. It becomes a little bit more expensive. We don't use that form very much, but it is appropriate for large, complex projects where we really need somebody there all the time to watch out for our interest. But this is what's called construction manager at risk, and this is the one we've used on this campus, where the owner has a contract with the architect. Again, the architect communicates with his consultants. The CM at risk, meaning they are taking the risk financially for the project. We'll work with subcontractors. This is basically a general contractor. And the difference between this and design bid build is we have advertised and selected an architectural firm, design firm. Shortly after that, once the schematic design has started, we are going to advertise for a construction manager at risk. And rather than doing a bid process, they would come in and give us a interview, show us project that they've done in the past, and we would hire them at that point, whoever we select, to be the construction manager at risk, and they would then come in and sit in on the design portion of the project, and they would bring up to the design team any issues that they think might need to be changed, because the construction manager at risk is going to give us a GMP during the final phases of the design. They'll be giving us budgets throughout. We'll be looking at doing some of those value engineering items during the design process. If they say no, it's not, we can't do it for that amount of money, you're going to need to lower something's got to give. We would take that out. So the CM at risk coming in at the design phase is basically saying, we're going to look at this design, we're going to bid it, we're going to give you questions up front before we give you your GMP to try to get this thing down. Now, it is a team concept. It becomes very, the communications is very involved. There are a lot of meetings up front that says, talks about things that are coming up. They may come up with a general budget that says this is what we can build this project for at this design phase. And we look at that and say, well, that's a little over our budget, or that's good. We may be in good shape. Let's keep going. But all of those things are discussed ahead of time. But again, the one thing that can really cause issues is scope creep. It's difficult for the owner to evaluate validity of GMP and value of contract based on what they're giving us, but we are having the contractor and the architect and design team talking constantly during the design phase, so it's a very easy thing to work with. It is sometimes not legal in public projects in many states, again because of the fact that there could be some collusion where people are kind of doing things under the table that they shouldn't be. But if things are above board and everything is listed out and itemized, then it's not a bad way to go, and it certainly does save time. And without scope creep, that GMP should be valid unless there's something unknown. This is especially true for a renovation project. If you run into things that are unknown, those things could be lead paint, they could be asbestos, they could be PCBs, anything that has a regulatory look to it or becomes an issue after the fact can cause some issues with the GMP. But if everything is pretty straightforward, you can expect that the GMP will stand up, and there should be very little in terms of change orders during the project construction. If they mess it up, if they made a mistake on their GMP, there are ways for them to increase, say, price of fuel goes up. That may be written into their contract that if fuel goes up by a certain percentage, then we're allowed to add an additional amount to our contract. But for the most part, the GMP that they're giving you should be let's say set in mud. It's not set in stone, but it's set in some stiff mud, so that at least you feel a little bit more confident going into this that you're going to be able to afford to get the work done. There is the CM as an advisor, and this is basically a construction manager that gets hired by the owner to watch out for the architect and the contractor to be in the best interest. So if you're doing a design build, you could maybe even add a CM as an advisor to come in and work outside the architect and contractor in your benefit to make sure things are working well. Complaints issued include errors and omissions in design, and errors and omission are always a thorn in my side when I see this happen, because architectural and engineering firms generally don't like to take financial responsibility for errors and omission. I've seen it happen a couple times where they've come up with money to take care of these things, but it doesn't happen very often. I remember one issue when we were putting in the Sean Walsh Hockey Center. We have a laundry system in there that washes hockey uniforms, which can get pretty nasty. And it requires a heavy-duty commercial-grade laundry facility. And for some reason, the architect, when they put the specs together, had written it for a residential-style washer and dryer. And all of a sudden, we get in there, and it had slipped through. And we looked at it and said, and we had written before in our scope, and we wrote what we wanted. We needed commercial-grade washers and dryers, and they put these things in and they just wouldn't work. So they ended up actually having to pay some on the upgrade to go from a residential style washing machine to a commercial grade industrial laundry machine, which ran off natural gas or propane, and was heavy duty enough to take an entire team's laundry after a game, put it through there, the pads and all the heavy duty stuff, and make it work. But it became an issue. We had to fight our way through it. Eventually they came through and took care of some of the project, but in also the university, or the owner in this case, also took some of the financial burden from that for not paying attention, which would have been my responsibility. So something you need to look out for. Defects in construction, coordination problems. We don't want the painters coming in before the drywall's done or sanded properly. So there's all those issues of making sure that things come in the proper order. Delays, cost overruns, adversarial fault-based relationships. Seen it happen. Seen contractors that have become adversarial with the owner's project manager, and really working on a basis of trust and just making sure the communications are there. You don't want to start out a project by being adversarial towards the contractor and assuming that they're out to get you. You need to work with them, and if you start that adversarial communication line, it just kind of builds and things get worse and worse. And from that standpoint, you really need to kind of be as organized and coordinated and use as much common sense as possible to keep the job running, keep people relatively happy, and just working with the system. The reasons include multiplicity of parties with conflicting interest and motivation, of course, who you're working for. Incompatible cultures, don't see that too much. Poor communications and limited access to necessary info, leading to numerous RFIs, request for information. A contractor will immediately start putting in, after a bid, especially a design bid build, where those things that were left out of the specifications for clarification will start asking for requests for information. Do you want this, or do you want this? Which one is it? This one's going to cost X amount of dollars. This one's going to cost this amount of dollars. I only carried the lower price one. If you want the more priced one, we're going to have to issue a change order. It all becomes an issue of communication. This is something that's come up recently in the last few years, is integrated project delivery. And I'm bringing it up. It hasn't really taken effect yet. It has to do, it's kind of like the total TQM, total quality management, where everybody has got their arms around each other singing Kumbaya. And here's the definition. An IPD is a project delivery approach that integrates people, systems, business structures, and practices into a process that collaboratively harnesses the talents and insights of all participants to optimize project results, increase value to the owner, reduce waste, and maximize efficiency through all phases of the design, fabrication, and construction. We're all going to get together in a circle around the fire, and we're going to sing and talk about how this is going to happen, and we're all going to work together because we're all in this as a team. Hasn't really taken off on any projects that I've been involved in, simply because it requires people to lower their expectations of what they're doing and who they're working for. They're trying to say with this IPD, integrated project delivery, that we're all going to work on this together. Nobody's going to get any more out of it than anybody else, and we're all going to be happy. And it's tough to get that to work. The projects where the key participants are involved from an early stage of the design, project is jointly managed by the project team, which could be the contractor. Basically we do this anyway, but the risk and the reward are shared based upon project outcome. Tough one to handle, especially where I'm working for a university and we're dealing with nonprofits. We just want to get the project done. How we share the outcome, we're not going to get any profit out of this thing that's going to be shared back to us. We could get cost savings, that works, but it's definitely difficult to get contractors and designers and everybody to work on the same page and open up that line of communication that lets us know exactly who's doing what, how much money's being made off this thing. People are going to definitely have issues with that. So the integrated project delivery includes collaboration, joint management, shared risk and reward. Again, something that's difficult unless you're within a very close group of people and know each other really well, is probably a difficult process to use. And the AIA promotes this, and I'm sure that this whole shared risk and reward is appetizing to some entities, but possibly not as much to the owners. The legal relationships, the owner, the architect, and the CM actually having all contractual relationships may be beneficial, because no longer do you have this dotted line between the architect and the engineer and the construction manager GC. It becomes a contractual issue where if something goes wrong, all three parties are going to lose. If something goes right, everybody's going to benefit, but the architect may benefit more than the GC, and the owner relatively benefits financially very little. So if you're a private business, a hotel, something like that, this whole process may work very well. But if you're using public money, this triangle may not work quite as well. The principles are early involvement in key participants, mutual respect and trust, transparency, advanced technology, BIM or building information modeling, early goal definition, intensified planning, collaborative decision making, and shared risks and rewards. It's a great thought, it's a good idea, but it takes just the right type of project to make something like this work really well. They give us some more benefits here on predictability of outcomes, fewer requests for information and conflicts. If we're talking new construction, this could work really well. If we're talking renovation of an existing building, not so much, because there are so many unknowns that we run into when we talk about renovations. Building information modeling, and the second half of the semester we'll get into building information modeling more. It's the process of generating and managing building data during its life cycle. We're not just designing a building and constructing it and walking away. We're looking at its life cycle, the design, the construction, the occupancy, the life cycle with regard to length of time that you're going to be in the building, how well the building is working, energy-wise, conflicts during the design process can be picked up. So we're using a three-dimensional design process to incorporate information on building components that is going to be a permanent part, and it includes those fourth, fifth, and sixth dimensions where we can look at a product that we want to use in the building, place it in there, see how it's going to work, see if it's going to interfere before it ever actually gets onto the site. So building information modeling is a function. This is a wireframe of a building that we can see a lot of the components, and in this case the wireframe is the structure, and what we're looking at here is the HVAC system. It's built into the model. We can look at it, we can see where we're going to have some conflicts, where we need to incorporate things before we get onto the job site. The advantage being that we've looked at that, we've determined the conflict, we're able to export our drawings from this model so that all of those conflicts will disappear. We shouldn't have nearly as many requests for information on the layout of how things are going into the building. Now, if we look on a website, I'm going to pull up this website. It's called ARCAT. ARCAT is a architectural catalog that includes a CAD library, spec library, building products, and we used to have something in the old days of board drafting that was suites catalogs, where you can get all this information. Now it's all on electronic formats. So if I were to look at BIM content, I could pull up and I could search for, let's go to doors and windows, something I'm relatively familiar with, and we can see here's a steel doors and frames. And we can go down and see that the Republic's Doors and Frames has 32 BIM products available. And we come down through this. Here we see curtain walls, double steel doors, rabbeted steel cased openings, and these are available in RFA, which is a Revit form. And if we, I don't know whether I can pull this up, double rabbit. Let's see if I just click on that. Oh, that's a request for information. If I want to request for information on this particular product, I can fill out a form and the company will send it to me. What I'm really looking at here is the RFA. And if I click on this 2013, meaning that I've got a 2013 copy of Revit, I can also download it as an AutoCAD file, a MicroStation file, or a DXF file, which is most common. And we click on this, it's going to actually open up my Revit program, which you can kind of take a look at, even though we won't be getting into it till next semester. But I just wanted to give you a taste of what this building information modeling involves. So it's going in, it's upgrading that model for me. I'll give it a few minutes. Take a drink of coffee. Ooh, cold coffee. So we'll look at this. It's got the information on, there's the plan view of that double door that I just brought up. And it gives me what the plan view would look like here. But I can also look at this as a 3D view. I just double click here. And I can hold down my shift and we can actually look at what this double door would look like in a wall assembly. You know, very easy to work with, but I can also see what it looks like in a plan view. So if I open up this project 1, I was playing around with this earlier. So this is actually, if I look at this in a three-dimensional view, I have an overhead door in here. Let's say I want to put that pair of doors that I just grabbed into this. So I'm going to go back to my level 1 and I'm going to come up here and go to my, I'm just going to say load into project. We'll see if this works. So now if I want to place that door, I can go to architecture, door. There's my double door right there, and I can put it on either side. I'm going to put it right next to this overhead door so you can see it better. And we'll just place it right here. Now if we look at it in a 3D aspect, there's that double door placed in the wall on the floor plan. If I just want to see what it looks like on the floor plan, we pull it up here. We can dimension things from center line to center line. But I think one of the big things here, if I look down here at my schedules, I can look at my door quantities. And I just double click this. It's going to bring up the fact that I've just put in a overhead door, shows up here. I've got an exterior solid door, and it's by the manufacturer, Republic double door. Has some information here. 3x8, and it gives me some quantities. I've got 2 door panels, 3x7, that are going to make up this steel door here. 4 generic handles, gives me some information. Now let's say I wanted to make this a custom door. If I come here and let's just change, actually let's change the width of this to a 5 foot and see what happens. You'll notice that my 2 door panels went to 2'6", and if I go back to my floor plan, you'll notice my door shrunk to a 5 footer. So these are very easy to deal with. I can look at it in a 3D mode. So I've just put all that information in there. Whoops, gotta go 3D here. Now it's a 5 foot door. I can look at it in different views. I can actually zoom in and actually give it a fine detail and show what it looks like as a realistic rendering. So it's all very easy to deal with, and we'll be dealing with this in the second semester, where we'll be designing some things using Revit and bringing in some of those BIM models from outside to work with. So just something to give you an idea of how BIM works. And again, it's kind of like that consultant to the architect relationship in the building process. Now we have manufacturers who are more than anxious to provide BIM models of their product that architects can just grab off the internet, drop into a drawing and say, yeah, that looks good, maybe make some changes to it, but now all of a sudden the specifications that go along with that are included in the bid package as part of the system. And those drawings from, if we go back to the PowerPoint here, that's the one I was in. Oops. And we'll look at this. There we go. ARCAD again. If we look at these divisions and whatnot, and again, we'll be talking about it later. Under the BIM content, doors and windows, we were looking at steel doors and frames, Republic doors. You can see that all that information is in there. But in addition, if I double click on this, maybe, yeah, it's not going to give it to me, but I can go to the spec wizard, go to doors and windows, look at steel doors and frames, and I can look at the actual document that specifies this particular product under section 08110, and now all of a sudden here's our specification as a Word document that's already written. All we have to do is go in and proofread it, take out the stuff we don't want, add the stuff we do, and we've got our specification written for this particular item within the construction document. So again, we'll be going over this a little bit later in the semester, but just give you an idea of where these things are and how easy it is to get to them on the internet and download them into your particular project. So we'll deal with that a little bit later. And that is it. That's probably enough for this week 2 lecture. Thanks.